Hey, this is just a quick Chapter 5 Algebra 2 review. I'm going to do a couple examples from each section. So let's start with Section 1. Section 1 was all about transforming the quadratic or the parabola and also graphing it using a table. So I'm not going to walk through this examples 6 and 7 here. These are from the back of your book. Basically, you can use the table from your graphing calculator. Remember that second graph in order to get the formula. You always type this in y equals. You plot the actual dots you see there as x and y coordinates, and you come up with a graph like this. Let's jump to the transformation one. So let's do number 8 together. Number 8 has a few changes. Let's talk about what's happening. We know it's a quadratic because of the square. We know we're moving right 2 because we're subtracting 2 on the inside. And we know, since this is on the outside, that we have a vertical stretch by a factor of 4. Let's jump over here. I made a little summary chart here of your notes that we keep using over and over. So the first thing you do is you ask yourself, is my change happening on the inside or the outside? And for this -2, it was on the inside. So let's go over to the chart. We notice here is where we have our inside changes. So we know that we're going to make a change to x. And x goes left and right, so we use the words that are here. And we also use the fact that it's opposite, so we say right 2. Then we notice that we're multiplying by 4 here. The multipliers, whether on the inside or the outside, are the stretch and compressions. Since this one's on the outside, let's go over to our chart. You'll notice that since it's on the outside, it's a change to y, so we use the word vertical. And it's what you see is what you get, and since 4 is a big number, we say stretch. Let's go to number 11 here. Number 11 has several changes happening. Let's start with the negative. You remember that when there's a negative involved, we just say reflection. Okay, that one's easy. The +2, again, let's go over here. It's happening on the inside, so it's a change to x, so we know our words are left or right. Since we're adding 2, we know we're going to say left, because we do the opposite of what you think. So we have a reflection, left 2, and then the +6 is happening outside the function. So let's go over here. Since it's outside, we say that we're going up 6. Okay, let's do one of these down here. Let's start with number 12. Number 12 is telling us that we're starting with the parent function, f of x is x squared, which is the whole chapter. It's going to be reflected across the x-axis. We're going to take that change over here to the PowerPoint slide, and that makes me put a negative there. Okay, so far I've just done negative x squared. Then it tells us to translate it 3 down. Okay, 3 down. So let's go to our chart here. Down is obviously an up-down change. It's a change to y, so it happens on the outside of our parentheses, and it's what you see is what you get. So we say -3. Number 13. Number 13 starts with x squared. It's vertically stretched by a factor of 2. A vertical stretch means multiply. The word vertical tells you outside. So we take the 2 and we multiply it on the outside. We also apply what you see is what you get. So that's where the 2 comes from right here. The next part of the change is translated 4 units right. Since it's 4 units right, we're going to go here to our chart. Our left-right changes are over here. They're on the inside, and they're opposite of what you think. Since we're going right 4, we subtract 4. Okay? A lot of you missed these on the quiz. You might want to look back over your quiz. Double check your mistakes for how you do transformations. Pay attention to the formatting. Okay, just a quick reminder, on the wiki is also a video for 5.1. So let's jump to 5.2 and let's look at these problems here. All of these problems are the same. They want you to walk through the steps of finding the axis of symmetry, whether the graph opens up or down, etc., and then plot it onto a graph. So I'm going to jump to the PowerPoint real quick. The PowerPoint here is relative to these problems. This PowerPoint is linked on the wiki, so you can walk through it there, or I'm going to walk you through it real quick here. So we remember that when the first term's positive, it opens up, negative opens down. That the axis of symmetry formula is negative b over 2a. You're welcome to put this on a note card. And that you plug in that axis of symmetry back into the formula to get the y value of the vertex. Now I will say this is where most of you get confused. You think that the y value of the vertex here is the y-intercept, and they're two totally separate things. So understand that the y-intercept, which is found by C, is an actual point. So let's jump through an example. Find the axis of symmetry, negative b over 2a. We got 1. To find the vertex, we take this 1 and we plug it into x squared minus 2x minus 3. After we plug in that 1, we get a y of negative 4. You can also use your second graph or the table from your graphing calculator to confirm that you did your math right here. We now have a vertex at 1, negative 4. Then we can find the y-intercept. This is pretty quick. It's right here at negative 3, so we plot that on the y-axis. And after we do this, a lot of you skip this step. We need to mirror the y-intercept over here across the axis of symmetry. And that's how you get your third point. Okay, the final point about section 2 is that it asks you if there's a minimum or a maximum. Minimum means low, right? Since our graph has a low point, we call this the minimum. What is the minimum? It occurs at the bottom, which happens at negative 4. Okay, section 3 was about solving quadratics using factoring. We also did a little bit of graphing for this, and we spent several days on this. I'm not going to lie, most of you still don't have this mastered. You're just going to have to practice a little bit more tonight before the test and try to make sure you don't make the same mistake. So let's start with the simplest version. When a is 1, when the thing next to x squared is 1, you say to yourself, what multiplies to give me negative 30? Basically, you're breaking up this negative 30 into its factors, and when you break them up into their factors, they should add to give you positive 1. In our case, we got x minus 5 times x plus 6. Remember, at this point, this is where you can FOIL, first outer inner last, to make sure that you factored correctly. After you've determined you factored correctly, you set each of the parts, because of the zero product property, equal to 0, and you solve for x. Okay? So let's walk through these examples here and talk about which technique you'd use. In number 25, all of our values are already set equal to 0, and our a is 1. So you would try to factor what multiplies to give me negative 8, adds to give me negative 7. This does factor. You get answers of negative 8 and 1, so your actual zeros are at 8 and negative 1. In number 26, same thing, already set equal to 0. You say what multiplies to give you 6 and adds to give you negative 5. When you get to something like 27, you notice that you just have an x squared and a number. This is one of the ones from the quiz you just took. You do not have to bring the 144 over and factor. You can simply take the square root of both sides, and your answer is x equals plus or minus 12. You're still finding the zeros. Finding the roots or zeros or solving is all the same thing. You just go about it a different way. In number 28, for some reason this one always hangs you guys up, you think you need that third term. When you just have two terms, when c is equal to 0 and the first two terms have an x,